Welcome to ETE MCQs. Now let us solve a problem based on digital circuits. A positive edge triggered D flip-flop is connected as shown in the figure below. What would be the Q output in relation to the clock? Assume Q is initially 0. So we are given with a positive edge triggered flip-flop, which means that the output will be produced only at the positive edge triggering of the clock pulse. That is, the output will be, the flip-flop will be triggered only at the positive instant. Only at the positive edge triggering the flip-flop triggers. So it is a positive edge triggering flip-flop. So let us mention it clearly. So an upward arrow mark on the positive rising edge of the clock pulse refers to a positive edge triggered flip-flop, as well as if you have a downward arrow mark on the trailing edge or falling edge of the clock pulse, that is called as negative edge triggering. Now this upward arrow mark on the rising edge of the clock pulse refers to a positive edge triggered clock input. On the flip-flop is positive edge triggered. It is very clear. And Q bar is given as input to the D flip-flop. Q bar is given as input to the D flip-flop. So we need to have a knowledge of both Q and Q bar, because Q is your output and Q bar becomes the input of D flip-flop itself. Okay, the clock pulse and the respective output is given. We are supposed to find which particular option will be correct. Now before we proceed further, let us just have a recall the truth table of D flip-flop. D flip-flop, let us write it here. So you have input D and let the output be represented by Q. D is input and Q is output. So when D is 0, the output becomes 0. When D is 1, the output becomes 1. And this can happen only at the respective edge triggering of the clock pulse. Since it is a positive edge triggered flip-flop, only at the rising edge of the clock signal, this input will be processed and the output will be produced. So this truth table, or the output is produced, the flip-flop triggers only at the positive edge triggering of the clock signal. Now let us just represent the clock signal. The clock signal is a square pulse. And since it is a positive edge triggered flip-flop, let me just put an upward arrow mark. This is a positive edge triggered flip-flop. Okay, now this is your clock signal. Now it is very clear that the output is initially assumed to be 0. That is, Q is 0. Now let me draw Q and Q bar for reference. Now it is clearly mentioned that Q is initially 0. So let us just mention it as it is 0 initially. Okay. And if Q is 0, what will be Q bar or Q dash? Q dash will be 1. Q dash will be 1. When Q is 0, Q bar is 1. So it is assumed that it is initially 0. Let 1 remain here. And this is 1 and let this be 0. So when Q is 0, Q bar is 1. Now you can notice that Q bar is the one which is given as input to D. So at this particular edge triggering of the clock signal, the input will be processed and the output will be generated. That is what it means. The flip-flop triggers only at the positive edge of the clock signal. Q bar is given as input to D. So at this particular edge triggering of clock pulse, Q bar which feeds D will be produced at the output, because whatever is given as input to D becomes the output, or it is produced at the output. So Q bar, when it is applied to D, so you have 1 at this particular instant. During the first edge triggering of the clock pulse, you will be having 1 here. So 1, when D input is 1, the output becomes 1. So obviously the output Q becomes 1, and it remains 1 until the next positive edge triggering. And since Q has become 1, Q dash should become 0. Q dash at the same instant falls down to 0, and it remains 0 until the next edge triggering of the clock pulse. Q dash becomes 0, and it remains 0 until the next positive edge triggering. At this instant, you can notice that during the second passage of the clock pulse, you can notice that Q is 1 and Q dash is 0. Now this Q dash is given as input to D. So at this time instant, D input is 0. 0 when given as input to D, the output also becomes 0. So here the output drops down to 0, and it remains 0 until the next clock signal. When the output drops down to 0, Q bar obviously becomes 1, and it remains 1 until the next passage triggering. Now this Q bar becomes the input to D. Again the output becomes high, or output becomes 1, and it remains 1 until the next passage. Here, since Q is 1, Q bar will obviously drop down to 0, and it remains 0 until the next passage. And the cycle gets repeated. Here it will drop down to 0. The Q bar will obviously become 1 in this case, and it keeps going. So you can notice that this is your respective output. At each and every edge triggering of the clock pulse, you need to focus on what is Q bar, because that Q bar will become Q, and whatever value Q gets, its complement will appear at Q bar. So this is your respective output. Now which option has got this output? You can notice that option D is fine. Option D very well matches with the waveform representation of what we have obtained. Waveform based analysis will help you to understand the functioning of flip-flop very well, and it will also help you to identify what change will happen at what particular instant. Okay, and the same can be applied to any flip-flop, and it can be applied to T flip-flop, JK flip-flop, whatever may be the flip-flop. Just understand the basic principle. Only at the edge triggering of the clock pulse, the input should be processed and the output should be produced. So option D is correct for this case.